So in this video, we're looking at transformer calculations where it's not an ideal transformer. Okay, so with these type of questions, power in is equal to power out only if power factor is not included and there are no losses. So since there are losses, transformers cannot be 100% efficient. So with ideal transformers, power in is equal to power out. Efficiency is equal to the output power over the input power times 100%. So the input power is going to be the output power plus copper losses plus core losses, noticing that your output must be a smaller number than your input. So remember that the numerator will be a larger number. Okay. So again, the input power is equal to the output power plus copper losses plus the core losses, which means that the denominator will be a bigger number. The numerator must be a smaller number. So output is equal to input minus copper losses minus the core losses, which will give you your output, meaning that your output will be the smaller number. The input must be the larger number. So input is equal to output plus copper losses plus core losses. The input will then be the larger number. The output will be the smaller number. So all you have to do is to make sure that your input is always greater so that you get a percentage less than 100%. So magnetomotive force means MMF. So MMF on the primary equals MMF on the secondary. Now we get the magnetomotive force is Fm, which is I times N. The P means primary side. So I times N on the secondary side. So Fm is equal to In. Fm is equal to In. By primary and secondary, right? Power factor. Power factor, the definition of power factor is the ratio of true power to apparent power. So the formula for power factor would then be true power over apparent power. And the answer is anything between 0 and 1. Okay, answer is anything between 0 and 1. Meaning it's 0 comma something, but less than 1. Power factor equals cos theta. Cos theta is power factor. The formula for true power is VI cos theta over VI, which is the apparent power. So true power is VI cos theta over VI, which is the apparent power. So true over apparent. What is true power? True power is the actual power. This is also known as the real power. So true power involves using cos theta. So the formula is power is equal to VI cos theta. So the real true power is the power actually consumed due to the resistive load. So the resistive load is the load that's on the end. Apparent power is the resultant of the triangle, the average power, power true, and the reactive power. Okay, so the apparent power is the hypotenuse, the true power is the horizontal, and the reactive power is the vertical. So looking at cos theta, it would definitely be the true power over the apparent power. Recall power factor. Power factor equals cos theta, meaning it would be the horizontal over the hypotenuse, and that would be cos theta of that angle. Right, single phase transformers, the transformation ratio. Don't forget, transformation ratio is NP over NS is equal to VP over VS, but they're directly proportional, so that's why it's P on the numerators. But notice with the currents, it's S on the numerator. So not many questions do they use the currents, but if you do get the currents, don't forget it's going to be S over P. Right, the two types of questions for efficiency, the losses calculation and efficiency, we get type 1 and type 2. In type 1, notice there's a power factor. In type 2, there's no power factor. Looking at question number 2, no power factor. Right, so these are the two types of questions we have. You can write them down. If you want, take a photo with your cell phone, do them, and then look at how I solve these two for you. Okay, and these are the types of questions that come out in exams. So do make sure you have all the transformer calculation knowledge. Also refer to the textbook. There are more questions in the textbook that you can do for practice. Alright, so answering the first question, they wanted to know what's the total losses. The total losses is equal to the iron plus the copper losses. Iron plus the copper losses. So all you have to do is adding up the two losses together. The iron losses were 400 and the copper losses are 450. So 400 watts plus 450 watts will give me an answer of 850 watts. Okay, and that's our total losses. Question number 2, it says calculate the output if the power factor is 0.8. Okay, so this means we're not getting 20,000 voltamps. So how we know that the apparent power is 20,000? Simple, because they told us 20 kilovolt amps. So when you see the unit kilovolt amps, this means they're referring to apparent power. So here they said the power factor is 0.8. So this means it would be 0.8 times of the 20,000, which would give us an answer of 16,000 watts. Right, question number 2 is still moving on, and we know that we have to find output power. So output power is equal to the input power minus the losses, and our input power was 16,000 watts, right? Minus the losses, which you calculated in number 1, 850, and this will give us an answer of 15150 watts. Now, the next question, number 3, calculate the efficiency, including the effect of power factor and losses. So next question, the efficiency. So efficiency is equal to the output over the input times 100 to convert it to a percentage. So output over input times 100. Now we already calculated the output power in number 2. So you can just substitute the number on the top over the original input. But however, I'm going to do the whole thing again, because most questions, they will go straight for the kill. So input power minus the losses over the input power times 100 to convert it. Right, so taking our numbers, substituting it there, we're going to get our 16,000 minus 850. Place that in the numerator and 16,000 in the denominator. Notice that the numerator will be smaller than the denominator, times 100, and that will give us an answer of 94.69%. In question 2, it says, again, 20,000 volt amp transformer under a full load, the same numbers, 400 watts and 450. So we want to calculate the total losses. So we know our total losses there is going to be 850 watts. Nothing different to before. Then it says, calculate the output power. So we have to go in there. So the output power is equal to the input power, subtract the losses. So notice that our output power was kilovolts amps, which is 20,000 watts. Okay, so kilovolts amps, 20,000 watts, subtract the losses, which were 850, and now we get an answer of 19150 watts. So notice here, there's no power factor in this one, which means we're just working with the apparent power minus the 850 straight. All right, the next question said calculate the efficiency. Question number 3, efficiency again is the output over the input times 100 to convert it to a percentage. Now the output must always be smaller than the input. So input minus the losses. Okay, input minus the losses. So don't forget our input was 20,000 now, minus 850 over 20,000 times 100 to convert it. And now we get an efficiency of 95.75%. Okay, and that's how we do these questions where there's efficiency. And those are your 2 major types. Okay, so here's another question that you can practice with. This one says a 20 kVA transformer. So because you see kVA, you know that it's going to be apparent power. Has a transformer ratio of 50:1. This means it's a step down transformer because it's 50 on the primary and 1 on the secondary. And the total losses amounting to 800 watts. So here they gave total losses already. It has a primary voltage of 440 on the primary side and 800 turns on the primary winding. So here it says it has a primary voltage of 440 volts and 800 turns on the primary winding. The output power at a power factor of 0.901 is 18.02 kilowatts. So do note that 18.02 kilowatts, because you're seeing a unit kilowatts, you know that is the true power already. So they gave you the losses and they're given the true power in this question. Okay, so the first question says the number of turns on the secondary winding. The number of turns on the secondary winding. So to calculate that, we'll use the formula NP over NS. And we get a transformer ratio of 50:1. Now to calculate NS, we know that there's 800 turns on the primary. So if you read the question, it says 800 turns on the primary. So then it's going to be N times 1 over 50. So N1 times 1 over 50. So we need to make NS subject to the formula. So NS is equal to 800, which was N1, times NS, which is 1, divided by 50, which is on the primary side. Right? And we get NS is equal to 16 turns. So 582 wants us to calculate the current on the primary side. So the primary current is the second question. So calculating the primary current, we know that S is equal to V times I, but we both have to use the both primary numbers, which will be Vp times Vi. And then make IP subject to the formula. IP is equal to S over Vp. We know that the apparent power was 20,000 divided by the primary voltage, which was 400 volts. And then IP is equal to 50 amps. In the next question, number 3, they want us to prove that the power factor is indeed 0.91. So remember what power factor is according to the formula I gave you. It's the true power over the apparent power. Substituting the true over the apparent, notice it will be the kilowatts over the kilovolt amp values, because kilowatts is true power, apparent power is kilovolt amps. So it will be the true over the apparent. So the true is 18 020 divided by 20,000. And then we get the answer 0,901. And so now we have proven that the power factor is indeed 0,901. I hope these calculations are quite easy. Do watch the video again to understand, and check the textbook for further examples and past papers.